Okay. The last formal lesson we did together was a 2-day lesson in which we did an experiment. The experiment was called Capture Recapture. And so I went ahead and did the experiment myself at another time. And I did not report all the results here, but I reported some of them. And my question to you is, based on these results, how many beans are in the cup? Got a whole bunch of confident people. Nice. We got Kiara, Aaron, Benjamin, Ethan, Amaya, Yasmin, and then Dalia. Go. 588. Okay. You think it's 588? That's interesting. The first two people said the same thing. Go ahead. Okay. Ethan? 550. Okay. Amaya? 588. Okay. Dalia? Oh, I've called on like 7 people, 6 out of 7. Say 588. That's interesting. Because it's 588. Wow. Got 21 people in the room. I got 7 magicians. That's pretty impressive. A very high ratio of magician to average student. Right? You used magic to do that? Oh. Seems kind of magical to me that you would get this, everyone would get the same number of 588. It's weird. How'd you do that?
I did an immersion for all the recaptures. I got the answer problem, and then I did that animation.
Oh. How'd you learn how to do that?
You have to add up all the numbers and then
No, but I mean, how'd you learn how to do, like, you described everything really nicely. Where'd you learn to do all of that? The proportion, you said proportion, and this and that. Where'd you learn how to do that? When?
2 weeks ago.
Doing what?
What?
Okay. Benjamin?
Doing the same thing. Doing the same thing you did.
Yeah, we did this together as an experiment. You did the experiment yourself. In fact, you have the results in your binder. Huge data sheet with all this information except just different numbers. Her description and his description was beautiful. Yeah, I was just playing a little bit dumb on purpose because I was trying to bring light to the fact that some of you just did whatever you wanted because you said, oh, well, there's a list of numbers, so that means add the list of numbers and then do something with it. But you didn't think about everything that had been presented to you. I even went over to a couple people and pointed out the fact that we actually did this experiment and that there might be something that you could refer back to. So she described a proportion, and she even said, I did a proportion for each recapture. I love how she said that. Could you give me the first proportion you did for the first recapture?
7 over 61 is equal to 59 over x.
Solve the proportion, get a result, then do it again for the second recapture, third recapture, fourth recapture. You get 4 results. And then you did what?
I made the average.
Yeah, she found the average of the results. And the average comes out to 588. Give me a thumbs up if you got the 4 different results for the 4 different recaptures. Could someone read them to me? What are the 4 results? Delia, what'd you get?
The first recapture was 514,
Mm-hmm.
then 811,
Mm-hmm.
then 425,
Yep.
and 588.
Sounds about right to me. So now look down the list and any observations that you would like to make about the list of results. These are the results. Any observations about the results? Khalid? Very interesting observation. It's 811. Something's going on there. There was a word to describe that. What was that word that you learned to describe that 811? Really important word. Justin? Yeah. It's an outlier because we've got everything else close to 500. This is 14 away from 500. This is 55 away from 500. That's 82 away from 500. Everything's very close to 500, and then boom, all the way up in 800. So a scientist and you are starting to learn that you start looking for things like outliers, and then you have to actually make a decision. That maybe the outlier should not be included. Maybe the outlier was kind of like a weird result in the experiment here that didn't really count because it just something went wrong during that one recapture. Maybe I shook my hand differently when I put it in the cup or something. Maybe I did something different that I didn't realize I'd done that one time. So maybe, as a scientist, I say, well, I'm going to exclude this one, and I'm only going to do the average of the others, and then see what the result is. Maybe that would be a more accurate prediction of the number of beans in the cup. 514 plus 445 plus 582 divided by 3, now all of a sudden I've got 514 beans in the cup. It's a big difference. So that's something that scientists and mathematicians and all different types of people who study our world, they start to look for. Very important idea. Kayla, go ahead.
Okay, so if you remove the outlier, the 400, the 811,
Yep.
gotten it wrong.
You actually went ahead and removed it, so then you should. Did you get 514 or 13? You should have rounded to 514, but that's fine. So you can mark yours correct. So you went an advanced step. Now there's a problem with removing this one result. There's one other problem. Does anyone know what the problem is with removing this one result? Try. I didn't follow what you said. Oh, that's true, because we can never know exactly how many birds there are out there. You're right. You're right. But there's another problem here. Ethan, and then Yasmin?
Maybe since how Kayla did, she got with a different number than the rest of people.
Right, but I did that, and I already demonstrated that, and that's legitimate, but then there's another problem. Well, maybe you will, maybe you won't, but there's now a problem with the experiment overall. Yeah? Well, that's true, but now I'm going backwards, and so now I'm redoing it and saying I don't want to count it. But now there's a new problem. India? Say it again? Yeah, and what's wrong with that? Think about what we did in class. How many times did we do it? So why? Why did we do it 15? Remember, there was something I connected. I connected what we did to something you've done in another class. One of your other teachers taught you. Brianna? Yeah, to make what accurate? What has to be done to make it accurate? Oh, who taught you that? Ms. Mitchell. Yeah, the problem is now we don't have a lot of trials. In fact, 4 trials isn't really enough. So no matter what, I probably didn't guess nearly the right number of beans. But I didn't want to make you guys do 10 trials during a warm-up because that would have taken too long. So I condensed it down to 4. But for it to be a true experiment, you got to do 10, 15, 20 trials to really get an accurate result. Okay? Comments, questions, concerns? Good, we're doing fairly well. Today we're going to explore the idea of similar figures, but before we start that, let me back up for a second. we introduced the idea of proportion, and then we did a large experiment over the course of a couple of days. But one thing I didn't really introduce was the idea of a proportional relationship. And so what we're really trying to develop an understanding of is things in the world, ideas in the world, areas of the world that actually are proportional relationships. Not everything in the world is proportional. Some things are and some things aren't. So one of the things you're going to learn over the next couple of weeks is some different ideas and different aspects of our world that do represent proportional relationships. So one of your jobs is to be able to tell the difference. It's not easy. So when I developed the experiment that we did, basically what happened was that I made this situation proportional. I told you in advance it's proportional. And because it's proportional, we're allowed to use proportions to solve or find missing pieces of information. Today we're going to start exploring the idea of similar figures. This is a case in our world that is used all over the place. And similar figures represent a proportional relationship. So what are similar figures? Similar figures are two shapes, or more than two shapes, that have the same exact shape but are different sizes. Now let me talk about the word similar for a moment. Similar is a word we use very casually in the English language. Similar. I could very easily say that the blue of my shirt is similar to the blue of Yasmin's sweatshirt. I could say that. No one would dispute, no one would say that's, Mr. Gow, that's totally wrong. Because they're similar. They're not exact, but they're similar. So we use the word similar in the English language to describe things that are kind of like each other, but not exactly. But in the world of math, the word similar is a technical word. And it means very specific things. It means the exact same shape, different size. The exact same shape, different size. So a couple of things. This symbol, it's a little squiggly line, means is similar to. So you're going to see this all over your textbook, workbooks, tests, quizzes, FCAT. You're going to see it all over the place. This little squiggly line means is similar to. So for example, right here, I have a statement. It's kind of written in code, and we haven't really talked about this before. So what do you think this first symbol means? How do I read that? If I wanted to read that to you or you read it to me, how would you read that? Dalia? Close. That was a good idea. It's not points A, B, and C, but that was a really good thought. Aaron? Another good thought? Another good thought, China? Well, how would you read just this right here? I highlighted that. Say it louder. Triangle. So that's read triangle, and now you put it together with this, and that's triangle ABC. Well, what do you mean triangle ABC, Mr. Gowd? I don't know what you mean. Well, there's triangle ABC. Triangles are named by their corners. A, B, C. There's triangle ABC. And here is the squiggly line, is similar to, and now we have triangle DEF, and there's triangle DEF. So this is actually a statement. Triangle ABC is similar to triangle DEF. So I'm giving you an important piece of information. These two triangles are the exact same shape, different sizes. Exact same shape, different size. So, let me see if I did this. Let me show you what I mean. So, I know it's a little weird looking, but now I added in a third one. These are all similar to each other. So let me show you what I mean by similar. Similar means the exact same shape, different size. Watch carefully. Everyone look up here. If I use this corner, that's the exact same shape, different size, right? Now it's big. Now I'm shrinking it down so it's little. But no matter what, it's the same size. Watch what happens when I shrink it from here. Is that the same shape? That's no longer the same shape. So this is no longer similar to this and this. Let me back up for a second. What if I do this? Is that the same shape? No. It's only when I change the shape by both sides, the bottom and the side, and I can do that with this corner here. When I change both of them at the same time, that changes its size, but not its shape. It's staying exactly the same shape no matter what. That's an important difference. Okay? Comments or questions about that little demonstration? Yes?
Is that why they have a little square?
That's not why. Does anyone know what this little square means here and here? That's a very good thing that you pointed out, though. Shannon? Yeah, that's a right angle. And so what that means is this is a 90-degree angle right here, and that's a 90-degree angle right there. We're going to talk about angles and shapes more formally in a couple of weeks, in a few weeks. Okay? Any other comments or questions? All right, so we're starting to get the idea of similar figures. Now we need to go a step further. What can we do with it? Well, we can do a few things. We can prove that two shapes are similar. Or if we know that two shapes are similar, we can find missing pieces of information. So I'm going to start out by setting up a template for you. A blank proportion that we can use over and over again to have success. So we set up an empty proportion. A fraction bar equals fraction bar. I have two similar figures, two similar triangles here. So what we do is we take the first shape, put it down the first column, second shape goes down the second column. So what that means is we'll take a couple of pieces of information from the first one, a couple of pieces of information from the second one, and then we can do cross products or use any of the other techniques to find missing pieces of information. Now, you only need two numbers from each shape. But my shapes have three numbers. I've got a 3, a 4, and a 5. You don't need all three. You only need two. Now, before I continue, we need to talk about another big word. The word over on the left-hand side says corresponding. So corresponding. Corresponding means in the same position, different shape. Same position, different shape. Let me use this classroom as an example. Taylor is sitting 1, 2, 3, fourth column. She's sitting in the fourth column, the third row. That's her position in my room. Fourth column, third row. Remember that. Now, Ms. Williams' classroom is the exact same size and shape as mine, but it's facing the opposite direction. But because it's the exact same shape and size, it's a similar shape. So how would we go find the corresponding student in her class? Where would we find the corresponding student? Aaron? Yeah, we would have to walk out my door, walk into her room, stop right there at the door, and we would have to count over 1, 2, 3, 4 columns, third row, and that person is the corresponding student to Taylor. That's what corresponding means. It's a hard word to explain. That's why I'm using an example like this. Not only that, the person sitting in Ms. Williams' room is facing the opposite direction. Taylor is facing this way, which I think is north, and the person in the other room is facing the opposite direction, facing south. But they're corresponding because they're in the exact same position, just in a different room. So now, let's apply the idea of corresponding sides to these two shapes. So now I'm going to highlight a number. I'm going to highlight a side. Here is side AB. What is the This is side AB. What's the corresponding side in the big shape? So what I want to know is, in this shape here, which of these three sides, this one, or this one, corresponds to side AB? DeAndre? What were you going to say, Kiara? What did she say? No, what did she? DE. So this side here corresponds to this side here because they're in the same position, different shape. So let me pull information from the small triangle. So here I wrote the first shape goes down the left side. So let's use the 4 and 3. So I put the 4 here, and I'll put the 3 here. You're going to go ahead and do that along with me. But now, going along the top, I need corresponding sides. So now I need to know which side corresponds to the 4 from that small shape. Which one in the big shape corresponds to the 4? Got a bunch of people who know. Justin? Christian, do you agree? You think it's the 8? Yeah, it's the 8 because the 8 is in the corresponding position, but different shape. So it's right here. It's on the same matching side. Okay? So now what number is going to go here? Alex? The 6. The 6 corresponds to the 3. Now I can prove that these two are similar figures because I can prove that they form a proportion. I can do this. 4 times 6 is 24. 8 times 3 is 24. Since 24 equals 24, that means that is a proportion. And similar figures will form a proportion. So we're going to use this idea to solve all sorts of different problems. Similar figures is an incredibly important idea in our world. What's the tip that you have going on this quarter? Yeah, what's something different about the social studies fair project compared to all the other ones? Someone raise their hand and tell us there's one major difference between this one and all the other ones. Ethan?
And we're making a model?
Yeah, you have to make a model. Now, when you make a model, do you just draw it or just, mold it out of clay any way you want? Some people do, but you're actually not supposed to. Your model should be proportional to the object in real life. So if you want to do a model of the Capitol building in Washington, D.C., you actually need the measurements of the actual building, and then you need to use proportions to shrink it down to a size that you can build yourself. That's how we use proportions in the real world. Now, the person who designed and built the Capitol building in Washington, D.C., used proportions the opposite direction. Before they built the actual building, what did they make?
Model.
They made a model. In fact, before they made a model, they made a blueprint. From the blueprint, they made a model, and then from the model and the blueprint, then they started construction on the actual object. So this is an incredibly important idea in our world. Anything that's made, anything that's built, is designed in a model form or on paper before it's built in real life. That goes for cars, computers, iPads, e-readers, buildings, anything you can think of. Okay? Any comments or questions? I know I threw a lot of stuff at you. Good, now we're going to start using it. So, example 1. Which rectangle is similar to rectangle RSTU? Yes, you need to sketch all the pictures. You don't need a perfect picture. A sketch is good enough. Now, when I say sketch, this is not a sketch of a rectangle. That's kind of a piece of garbage. So, I'm not saying you need to use a ruler and draw perfect lines, but you can go like that and draw a rectangle. And then you can go like this and draw a bigger rectangle. Wow, that took me a total of 2.5 seconds. So my students who are already hanging their heads because they seem to be so exhausted, not an option. So everyone go ahead and take a moment, sketch the picture, write in the numbers that go with it, write in the letters that go with it. Not that hard. And then we're going to go ahead and use the ideas we just learned to explore this situation. So, which rectangle is similar to rectangle RSTU? Now remember, the word similar is technical. I'm not saying which one is kind of like it. I'm saying which one is exact same shape, different size. And you cannot just tell me which one you think is the one. You have to be able to prove it. Proving it is the most important thing. So I have some people who already understand and maybe already figured it out. That's fine. But what I'm asking is, which one of these three, this one, or this one, is similar to RSTU? So you could look at them and take a guess, but that's not good enough. So which one do you think, just by looking at them, which one do you think is the right one? India, which one do you think is the right one? Okay. Which one did you think was the right one, Taylor? So you also think. So since two people, so let's survey the class. Give me a thumbs up if you think EFGH is the one. Okay. Put your thumbs down. Now, Najee, do you know for certain it's the right one, or you just think it's the right one? You think it's the right one. Good, that's the right answer, because I know that you didn't prove it yet. Proving it is everything. Let's go ahead and prove it. So if we use the setup that I had introduced, where you have fraction bar equals a fraction bar, an empty proportion, and you take the first shape and you put it down the first column, and the second shape down the second column, and you line up the corresponding sides, if they are similar, it will form a proportion. So let's start with RSTU. We'll put the 3 and the 5. Someone tell us what number must go here. Justin?
6.
Good. China, do you agree? Okay, what word tells us that the 6 must go here? Yeah, it's a word you were introduced to in the past 15 minutes. Very good. They are corresponding sides. The 3 and the 6 are corresponding, and so they have to be next to each other. So what number must go here? Shannon? 10. So the 10 must go here. Now I need to see if this forms a proportion. If I can find a factor that when I multiply it here and I multiply it here, it's the same number, that will prove it's a proportion. Or I can do cross products. I can do 3 times 10 and get 30. And then I can do 6 times 5. I get 30. And those are equal. And so that proves that these are similar. So the correct answer is E, F, G, H. Yes, Keith? Okay. Now, one of these shapes, just by looking at it and looking at it carefully, you could tell was not going to be similar. Which one could you tell very easily was not going to be similar? Amaya?
M and PQ.
How could you tell?
Because it's like longer.
Yeah, but that doesn't matter. Maybe it's shrunken down in a way that makes it look a little strange. I mean, we have a short side, we have a long side. It just needs to be turned this way, and then maybe it would be similar. Yeah, is there a detail about MNPQ that absolutely makes it not similar? But that doesn't matter. I haven't talked about that yet, but that actually doesn't matter. Shape can be turned. Okay? Ethan?
A, B, T, C.
A, B, C, D. What about it?
It's not even a rectangle, it's a square.
It is?
It's not bad.
How do you know it's a square?
Because so far, if you look, each side is equal, like 5, 5.
Right? And so that proves it's a...
Square.
Yeah, you're absolutely correct. This is not a square because this side is different than this one. This is a square because this side is equal to this. And so you can immediately tell that they cannot possibly be similar because one's a rectangle and one's a square. And the whole point of similar shapes is that they are the same shape. Clearly, those are not the same shape. Now, the reason I disputed Amaya's thought was because that's a rectangle, and that's a rectangle. Just because it's turned doesn't mean it's not similar. And we're going to see an example of that in a moment. Okay? Other thoughts?
Every time when you find that they are similar, are they going to be like...
Not every well, not the way you think. No, not every time. Okay? So, example 2. So, in the previous example and during my introduction, all we talked about is whether or not two shapes are similar and how to prove it. But now we're going to shift things a little bit. Now we're going to get into the more algebraic type of idea, which is finding a missing piece of information. Now I'm going to tell you that these two shapes are similar. So when you see the word similar, then immediately you should be thinking to yourself, proportional. Similar means proportional. So you can use a proportion to figure things out. So immediately your brain should kick in. Okay, small shape, big shape, they're similar, which means it's the exact same shape, different size. And so I can use a proportion to find a missing piece of information. The first shape will go down the left side right here, the second shape will go down the right side right here. It actually does not matter the order that you put things in. I could put the 2 and then the x, or I could put the x and then the 2. It doesn't matter. What matters is what I do next. Because as China said, corresponding sides have to be next to each other. So if I put the x here, what must go right here? Caleb? The 7? Are you certain? Okay. Yeah, the 7 corresponds to the x because it's in the same position, different shape. So the 7 must go there, and the 5 must go there. Now you use whatever technique you would like to use to solve the problem. If you can find a factor to multiply or divide by, go for it. There's some bright students in here who can figure out some shortcuts. I cannot do it that way, so I'm going to do cross products, and some of you are going to need to follow along with me. And so we multiply the x times the 5, and we get 5x. And we multiply the 7 times the 2, and we get 14. And so we get 5x equals 14. Solve that equation. Divide both sides by 5. Divide by 5. And so the missing side will be what? Christian, what'd you get? 2.8. What'd you get, Yasmin? You also got 2.8? Yeah, comes out to 2.8. And so that means that that side of that triangle is 2.8 feet. Comments, questions on how we did that? Comments or questions? All right, part B. I promised that you would see a situation where one shape was flipped around. I was trying to convince you before that that actually doesn't matter, so I'm going to prove that to you now. I told you in the instructions at the top that these two shapes are similar. So we already know that they are proportional to each other. We're using that knowledge to find this missing piece of information right there. So we set up an empty proportion. The first shape will go down the left, second shape will go down the right, and then we'll line up corresponding sides. But now the idea of corresponding is a little bit more complex because the shapes are not lined up the same way. But that's okay, so we'll get to that in a second. It doesn't matter what numbers you start with. You could put the 4.2 on top and the 12.6 on the bottom. That doesn't matter. What matters is how you match up the other one. So I have the 4.2 on top. What must be on top here? Aaron? China, you agree? Yeah, the 1.5 matches or corresponds to 4.2. And then the x corresponds to the 12.6. So now we have a proportion set up. Cross product, solve the equation. 4.2x, 1.5 times 12.6. What does that come out to? Anyone got that already? Alex? Yeah, it's 18.9. And now solve the equation. Divide both sides by 4.2. Divide by 4.2. And what do you get for the value of x? Got 3 people who got it already? 5 people, 6 people, 7 people. Dalia, what'd you get? Justin, what did you get? 4.5? 4.5? Yeah, you get 4.5. Comments, questions, concerns? Okay, no comments, questions. So first we learned how to figure out if two shapes are similar. Then we were told that they're similar. Use that information to find a missing piece of information. Checkpoint number 1. Find the missing piece of information in each set of similar figures. Got 2 problems, you got 3 minutes. Minute and a half per problem. Nope, you don't have to draw the shapes, not with checkpoints. Colored pens up. What'd you get for part A? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 confident people. We'll start with Nicole and then Justin. Nicole, what'd you get? 13. 5. So we have a disagreement. Taylor and then Brianna. 5. 5. So we're now getting a little more support for 5 as the answer, Shannon. 5. The correct answer is 5. And what about part B? Part B was a little nutty because the shape was kind of rotated. We'll start with Deandra, Yasmin, Kayla. Deandra, what'd you get?
21.
21. You also agree. All three of you agree that it's 21. Correct answer is 21. So, if you didn't get it right and you used a proportion, then the only conclusion I can come to is you just put the numbers in the wrong place. So, there was a couple of different possibilities for this first one. (15/24), that's the first shape. Give me a thumbs up if that's the left side of your proportion. Okay, good. India, what was the right side of yours? Two, 8. Oh. Well, there's an X here. Did you put an X anywhere? Oh, okay, so that was a mistake. So the 8, you were right, the 8 goes here, but you accidentally put a 2 over here? Okay, so this was an X. So you had to put the numbers in the right place. I've been spending all this time talking about corresponding sides and numbers being in the right place, and some of you went back and then just put them at wherever you want. You can't put them wherever you want. You have to put them in the right place. Okay? Comments, questions? Okay? Example 3. You do not have to copy the text of the question. You have to read it, but you don't have to copy it. And you have to sketch the picture. Sketch means not perfect, but approximate. So a flagpole, you can draw like this, like that. A person, you can just draw a stick figure like that. That's fine. That's good enough. But then you have to fill in the numbers and the rest. So go ahead and take a moment to set up example 3, and then we're going to discuss. All right. Anyone seen this question or one similar to it anytime? Aaron? Okay, where? On the bat? On the bat test? Ethan? Last year you said? China? Care teacher, okay. But yeah, Aaron, and all of you are right, but Aaron said something really important, and you should have noticed it as well. This was on the bat. Now, you hadn't learned it yet, so that's okay. So if you got it wrong, it's not a big deal. But now you're not going to get it wrong again, and you're going to understand, and then take it one step further. This is one of the most classic math questions in the entire world of math classes. This type of question is used all over the world, everywhere. Sometimes it's a flagpole, sometimes it's a tree. So, and usually it's a person, but sometimes it's a different object over here. But usually it's a person and then a tree or a flagpole. That's usually how it goes. So here's the deal. If you want, this is called indirect measurement. If I want to measure something directly, I take a ruler and I hold it up against it and I measure it directly. That's called direct measurement. I can measure the length of the sign. But what if I have an object too tall for me to use with this, such as the flagpole in the front of the school? There's no way for me to use this to measure it. I don't have a crane at my disposal to lift me up, and even if I did, that means I would have to have the crane kind of go from the bottom and incrementally pull me up to the top. So years and years and years, hundreds of years ago, mathematicians figured out that we don't have to measure it directly. We can use our brains creatively to do what's called indirect measurement. here's what they figured out. And so you have to use your imagination here, and you have to look up here. Here's the situation. The sun is shining brightly right here. When the sun shines on an object in the middle of the day, it casts a shadow along the ground. Since the shadow comes directly from the object, it's proportional to the object. Mathematicians and scientists knew this. So here's what they figured out. If you have a flagpole, and then you stand close to the flagpole at the exact same moment, and let the sun shine, it will create a shadow right here and right here. Using your body and the shadow, and then connecting the 2 points at the end, you form a shape. Let's watch. From here to here, here to here, here to here. And then here, here, and here. And now look at what has happened when I take this and what does that look like? Have you seen this somewhere before? Yeah? Yeah, we did this exact same thing earlier. It was just flipped the other way around, but you can see the same thing right here. You can see the same thing right there. So what happened is using some basic science and some understanding of our world, we figured out that we could form two similar triangles just being creative. And so now we have two similar figures. Now we can find the height of the flagpole right here without having to actually measure it. And you'd be amazed at how accurate, if we actually were able to do this, which unfortunately we're not, but if we were able to do it, you'd be amazed at the accuracy. You have to do it a few times and kind of average the results, but you'd be amazed at how accurate you can get. And so all we have to do is solve the proportion that's formed from this to find the missing piece of information. So, same idea. Empty proportion. First shape goes down the left. X over 12. Second shape goes down the right, but you have to match up corresponding sides. So all of my students who messed up during the checkpoint, now hopefully you understand the importance of corresponding sides. So, Kiara, what side in the small triangle corresponds to the X in the big one? Which side in this triangle corresponds to the X in this triangle?
The 5 feet.
Yeah, the 5 is in the same position because we're looking here and here. So the 5 has to go here. It's not an option. You can't put it wherever you want. The 5 must go here, and the 3 must go there. Now, either use a shortcut or cross products to solve. Give me a thumbs up if you're able to use the shortcut with this one. You're able to do a shortcut? Go ahead, Chris. What's X equal to? Well, I asked if you could do the shortcut. You gave me a thumbs up. So shortcut means you can kind of do quick mental math. So I apologize if I misled you. Now I got a whole bunch of other people anxiously trying. So I'm going to go to somebody else. Deandra? 20. How'd you do that? Deandra, how'd you do that? Oh, you did the cross products, but I was asking for shortcuts. Where's my shortcut people? How do you do the shortcut? Yasmin?
3 times 4 is 12.
3 times 4 is 12. So now multiply the top times 4. 5 times 4 is 20. Or do cross products. You get x times 3 is 3x. 5 times 12 is 60. Divide both sides by 3 and you get 20 either way. And so the height of the flagpole is 20. Comments or questions? Good, let's see how you do on your own now that we've done a whole bunch of different things. Let's see who can handle this. You do not have to copy. You have to write checkpoint number 2 and then you have to answer the question. All right, how tall is the house? How tall? Got a lot of confident people. Start with Benjamin, India, and then Brianna.
35.
35 what? Okay, India? Okay. All three people think it's 35 feet. The correct answer is 35 feet. Now watch, because this was a slightly higher level question, and the reason is that instead of giving you the two pictures, look at what I did. Here, two pictures, right? Small and big. Here, two pictures, two pictures. Two pictures, two pictures that we compare, two pictures. Every single one of these had two shapes to work with. All of a sudden, you had one. So you had to either draw the picture yourself or understand in your brain what was going on. Here is what was going on. We were saying that the house in the picture, in inches, is the small shape, and it's 12/14. In real life, it's 30 here. What is that? So now looking at the picture that I've drawn, it should make a little more sense. And so you have to be able to interpret what is being asked. Okay? So Justin, you had done everything right, but you put the 30 in the wrong place because the 30 corresponds to the 12, not to the 14. Okay? Comments, questions, concerns? All right, draw a line across your paper. Your classwork is in the textbook, page 307. You're going to do numbers 5, 7, 9, 11, and 13. That's 5 questions. Got a couple minutes to get set up and going, and then 2 minutes per question. Okay, pick up your colored pen and let's see how we're doing with similar figures. There's this question again. And you were asked to write a proportion. I actually didn't put the answer to that. You could have had it a few different ways, but it should have been X. I'm sorry, sorry if I went too fast. Colored pen, now you're up here. So, the proportion using the triangles should have been x over 80 equals 74 over 26. So here is yet again another example of this classic problem. And then part 2 of that question was to find the height to the nearest inch, and it comes out to 228. Number 7 comes out to 15 millimeters, and number 9 comes out to 12.5 yards. And number 11 is 9 meters. And number 13 had 2 parts. We first had to figure out the height of the poster, which would be 3.75 feet. Then you were asked for the perimeter, so you had to now combine the information you found with the information that was in the question and calculate the perimeter, which is very simple. It's the distance around, 12.5. Comments or questions on any of these? Brianna, we'll start with you. Number 11 was very challenging. So, you're going to see something like number 11 again. So let's talk about this. It is basically the same exact thing that you've been seeing, except presented to you in a different way. So here's what you're going to do when you see this question in the homework. Redraw the picture separating the 2 shapes. So let's draw the small rectangle. So watch this. Here's the small one. And here is the bigger one. So that's the picture that you're given. So now let's actually separate them and fill in the information. So here's the small one, and now here's the big one. Now watch, here's where, and everyone needs to watch, because even though some of you got it right for the wrong reason. The small shape is 14 meters and 18 meters. Now look at the big one. What's the distance from here to there? Aaron?
21.
Okay, I don't see a 21 anywhere. Where'd you get the 21 from?
Oh. Yes, 21.
Okay, but again, I don't see a 21 anywhere. Where'd you get the 21 from?
You have to add 14 and 7.
Yeah,
21.
this 7 is from here to here. The 14 is from here to here. You have to add them together, and that's 21 meters. Now the bottom, we know part of the bottom, but we don't know the whole thing. So let's just call the whole bottom x. Find the bottom. The bottom turns out to be 27. So the whole distance from here to here is 27, but this piece from here to here is 18. So what must this piece be? When you solve the proportion from this, 14 over 18 equals 21 over x, you get x equals 27. That's the distance from here to here. But in the original picture, it's broken into two pieces. This piece and then this piece. This piece is 18. The whole thing is 27. What is the distance there? Benjamin? 9. You had to do 27 minus 18 to get 9. Now some of you took a different approach and got a little bit lucky. Some of you said 7 to 14 equals x to 18, and you figured it out and it came out to 9 as well. You got a little bit lucky. So the whole key was separating the picture into its two component pieces. All right, draw a line across your paper. Your homework is page 307, numbers 6 through 14 even, and 18 to 24 even. That's 10 questions. And you're going to have a quiz. Let's see, Thursday. Monday. And that will be 6.1 through 6.5.